All right, so this last part of the notes is just some practice problems. I want you to try these. I'm going to go over them, but pause the video and see what you can do before you check out the solution. So go ahead and pause and see if you can do this first one. 4x squared minus 21x plus 5 equals 0. I want you to solve that. Okay, solving it means that we're going to use, we're either going to factor or we're going to use a quadratic equation. And I'm going to jump right to the quadratic equation here because I really can't tell if it's easily factorable. So I'm just going to go ahead and use the quadratic, which is up here, as we talked about. To start with, this is already in standard form, so I don't need to manipulate the equation at all. I'm going to go ahead and calculate the discriminant first. That's going to tell me how many solutions I have. So b squared, and that's going to be negative 21 squared minus 4 times a, which is 4, times c, which is 5. So I basically plug all this in. We get negative 21 squared. Let's see, negative 21 squared minus 4 times 4 times 5 is 361. There's my discriminant there. Okay, so that's a positive number, which means I know I'm going to have two solutions. And so I'm going to continue with my quadratic formula. Opposite of b is 21 plus or minus root 361, all divided by 2a, which in this case would be 2 times a, 2 times, and a is 4, so this would be divided by 8. So I'm going to go ahead and break this up now. I'm going to say 21 divided by 8 plus or minus root 361 divided by 8. And there's my answer. The thing that I want to check here, though, is if I can reduce either one of these columns. So first, can I reduce 21 over 8? And no, I can't. That fraction I can't reduce. What about this one right here? Well, if this right here, that radical, is not in simplest radical form, I would want to put it in simplest radical form. So the question is, with root 361, can I reduce that? Thinking back to 4.5, 4.6. Well, 361 happens to be a perfect square, right? 19 squared is 361. So 19 times 19, that works. So the square root of 361 actually just becomes a 19 here. Now, if we could reduce root 361 to something that still has a square root in it, we would still just bring it down to the simplest radical form. But in this case, it comes out really nice, and I have 19 there. So now my answer is 21/8 plus or minus, this is 19. So this is 19/8. All right, so I have my answer here, but because this portion of the problem reduced so nicely, and I don't have any radical in my answer at all, oftentimes it is best now to just continue with the problem and just actually break it up into the two pieces that it actually is. So what I mean by that is I have a plus or minus. I'm going to say, my first one is 21 plus 19 over 8. It's one of them. And 21 plus 19 is 40. So you can see I get 40 divided by 8, and 40 divided by 8 is 5. So if I actually take this all the way through, one of my answers is 5. My other answer would be 21 minus 19 over 8. And so I get 21 minus 19. Well, that's just 2. That's 2 divided by 8. And that equals 1/4. So that's my other answer. So, if you left your answer, if you left your answer like this, let's say, Well, technically that is still the correct solution. It's just not fully reduced. It's not fully simplified. So you'd get a lot of, if this was a quiz or an assessment, you'd get a lot of those points. Even if you got to this stage right here, even better. Again, technically that is the correct solution, but because this second part doesn't have a square root in it anymore, and my discriminant right here happened to be a perfect square, oftentimes it's best to just break it up into the plus and minus and see what you can actually get to. So 5 1/4 are my answers. Now again, if I were to graph this, take my standard form thing and let's say I graph it on Desmos. It's right here. 4x squared minus 21x plus 5. You can see that my two intercepts here are 1/4 and 5, which match up with my answers that I have. So another thing to realize here is that when you have answers like this, you have 5 1/4, and answers are nice, and you don't have any like irrational number, that's a sign that the problem could have been factored to start with. And so it doesn't matter which way you do it, but just to show kind of where we've come from and the different things that you can do, you should be able to factor this. So if you decided that, hey, I want to factor this into 2 parentheses, it should work out. So let's say we did that. You did the snowflake method. And so the a value is 4. A times c is 20. This is negative 21. So what multiplies up to 20 and adds up to negative 21? So we could say that's going to be negative 20 and negative 1. Those multiply up to 20 and add up to negative 21. And if we reduce this column, this would become 1/5 or negative 1/5, that one. And then this would stay as 4 over negative 1. So the factoring would become 1x minus 5 and 4x minus 1. So it can be factored. And if we did this like 4.4, then we set each one of these equal to 0, and we would get the same thing. X equals 5, and then this one would yield x equals 1/4. Same thing. So again, try to make some connections here. There's often several different ways you can solve this quadratic. The quadratic formula will always work, but understanding that some of these problems can be factored, and sometimes that's even a faster way to do it. All right, so here's another practice problem. Same thing. Go ahead and see if you can solve it. Pause the video, and then we'll go over the answer. All right, so this one clearly is not in standard form first. So we're going to put this into standard form by subtracting the 2x squared to the other side. That's going to give me 1x squared minus 3x plus 7 equals negative 4x. We have to then add the 4x to the other side. And so then we'll have standard form. We'll have x squared plus x, or plus 1x, plus 7 equals 0. So now that we have it in that form, this one is easy to kind of see that this is not factorable. There's definitely nothing to multiply up to 7 and add up to 1. I know I can't just factor it. I'm going to go ahead and use the quadratic formula, which is, all right, negative b plus or minus the square root of b squared minus 4ac all over 2a. And so I'm going to first get the discriminant, right? The discriminant is always something that we want to calculate first. So b squared minus 4ac, well, that equals my a value, again, is 1. My b value in this problem is also 1. And my c value is 7. So in this problem, I'm going to have 1 squared minus 4 times a, which is 1, times c, which is 7. So this will become 1 minus 28, which is negative 27. So my discriminant here is negative 27. Now I know that when we solve this problem, that means I'm going to have 2 imaginary solutions. So let's go ahead and finish it. So back to the quadratic equation, I'm going to have the opposite of b, which is negative, and b is 1. So negative 1 plus or minus the square root of negative 27, all divided by 2a, which would be just 2. So let's go ahead and break this up, right? So I'm going to have x equals negative 1 over 2 plus or minus root negative 27 over 2. We'll break that up. Now again, this is where, as we're writing this answer in a nice reduced exact form, the problem is right here, the square root of negative 27, that's a radical, and currently it's not in simplest radical form. So what I want to do is just take this root negative 27 and think about, again, in 4.5 and 4.6, how can I put that into simplest radical form? Well, I know that because it has a negative in there, I'm going to extract out the negative 1, and that's going to become an I. Then think about 27, right? There is a perfect square in there, and that's going to be, 9 times 3. So if I factor this out, I know that this negative 1 becomes an I. This 9 right here just becomes a 3. And the root 3 just stays as root 3. So all in all, this whole thing becomes 3i root 3. Okay, so now we put this into simplest radical form. Now we want to take that and put it into our answer that we are simplifying. So I still have negative 1/2, that doesn't change. Plus or minus now, the square root of negative 27 I know is 3i root 2. Because we just did that over here. All divided by 2. Again, looking at this answer, see if I can simplify or reduce any of these fractions or columns here. And I can't. I definitely cannot take divide out these 2's right here because one's in a root and one's not in a root. So this is as far as I can go, and this would be a nice, clean answer for that problem. Now again, as we've done all along, if we were to graph this equation, right up here, x squared plus x plus 7, because we have imaginary solutions, go back to the first thing that we did. Our discriminant was negative, therefore our graph should have no zeros. It shouldn't have any x-intercepts on the real number graph. So we can, again, double check that on Desmos. So if I go to Desmos and I pull this up, there we go. X squared plus x plus 7. You can see that when we graph it, we don't have any x-intercepts there because our answers are imaginary solutions and they don't show up on the graph.